Hello. Till now we discussed about overview of vector algebra, dot product and cross product, different coordinate system. So it has been noted there are the three different type of coordinate system. First Cartesian coordinate, second cylindrical coordinate, and third is spherical coordinate system. Then we also discuss about how to convert a point and vector from one coordinate to another coordinate system. So in today's lecture we discuss next topic, which is Del operator, and we'll also touch the definition of divergence, gradient and curl. Okay, so here this three definition is mostly depend on the Del operator. So first of all we have to study about what do you mean by the Del operator, what is the application of the Del operator. Okay, so let us start with the Del operator. So the Del operator, that means you have to represent the Del operator in all the coordinate system. So as we know that we have total three coordinate system. First is Cartesian coordinate system, which is x, y, z. Then cylindrical coordinate system, which is rho, phi, z. And lastly spherical coordinate system, which is r, theta, phi. Okay, so here you can represent the Del operator in Cartesian, in cylindrical and in spherical coordinate system also. Okay, but first of all we have to clear the concept about what is exactly the Del operator. Okay, and what exactly the Del operator do. So here the Del operator is represented using this sign. Okay, it is known as Del. Okay, this sign is known as Del and it is a vector quantity, so generally I would write in this way. Okay, it's a Del operator. So what exactly the meaning of Del operator? So I have to draw, suppose to understand the exact meaning of the Del operator, first of all I have to take a Cartesian coordinate system x, y and z. Okay, so now suppose here I have to draw one vector, the vector which is pointing from 2 point, suppose from origin to point P. Okay, so from O to P, suppose I have to draw a vector. So this one is my vector which is pointing from O to P. Okay, and I have to write the coordinate of point P. For example, the coordinate of point P is 2, 3 and 1. Okay, so what is the equation of this vector? So equation of this vector is known as ROP vector. Okay, so this 2ax plus 3ay plus 1az. Okay, so this one is my OP vector. So if you notice, this vector is a fixed vector. Fixed vector means this value are fixed. In x direction it covers 2 distance, in y direction it can cover 3 steps, and in z direction this vector cover 1 step. Okay, but suppose I have to draw one generalized vector. One generalized vector means those point has a any coordinate, that means x, y, z has a variable. Okay, that means the vector is present in any direction. Clear? So for example, suppose I have to draw one vector, this vector. So this vector is present on which axis? This vector is present on only x axis. Now this x has a any value. Okay, so I have to say that suppose this vector is a vector. So a is equals to x ax. Now here x is a variable. Okay, now I want to find out by how much amount of this vector is changed in x direction. Okay, I again repeat, by how much amount of this vector is changed in the x direction. Okay, then same, suppose the second vector is present in the y direction, and similarly the third vector is present in the z direction. Okay, so here I have to write, suppose this one is my vector b. So b vector is, for example, it is y ay, and this one is my vector c. So c is z az. It may be z square az, z cube az. Okay, कुछ भी हो सकता है. So a is equals to x ax, b is equals to y ay, c is equals to z az. Okay, and if I have to combine all the three, okay, so I have to get one vector. Okay, if I have to combine all the 3 points, so I have to get one vector. So suppose I have to write r vector is equals to xax plus yay plus zaz. It's a combination of all the three vector in all the three direction x, y and z. So this is known as r vector. Okay, so now suppose I want to find out this r vector is changed, or magnitude of r vector is changed in x direction by how much amount. Magnitude of r vector in y direction is changed by how much amount. Magnitude of r vector is changed in z direction by how much amount. Okay, so actually how much amount of the magnitude of vector is changed, it is indicate. Okay, so how can you find out it? You can find out using the Del operator. So using the Del operator, we can find out that how much amount of the magnitude of any vector is changed. Okay, so you can find out using the Del operator. Okay, so just I have to take one simple example. Suppose here one boy is standing, okay, with his motorcycle. Okay, boy is standing here with his motorcycle, and now the boy start to driving his motorcycle in one particular direction. Okay, so this one is a fixed direction, it's a road, straight road. So boy driving this motorcycle in this fixed direction. Okay, so here the direction is fixed, direction is not changed because the road is straight, but the velocity, but we assume the velocity of, okay, the velocity of bike is changed. Clear? So by how much amount of this velocity is changed? Okay, so we have to find out using the Del operator. Okay, so this is one of the application of the Del operator. We have to find out that how much amount of the magnitude of any vector is changed. You have to find out using the Del operator. Okay, then next, in which direction the magnitude is changed? Okay, so you can also find out the change in direction using the Del operator. Okay, so there are the three most application of the Del operator. You have to find out how much amount of the magnitude is changed, in which direction the magnitude is changed, and you have to also find out the how much amount of your scalar quantity is changed in any direction. Okay, that you have also find out using the Del operator. So there are the certain application of the Del operator. Okay, so first I will cover the what is divergence, curl and gradient, and then after we have to jump again to the Del operator. Okay, because actually it is difficult to understand about the Del operator. Okay, so first of all I have to explain to you what is the divergence, gradient and curl. Okay, then we will switch over to the again Del operator. Okay, so here I have to just take one example. Okay, I have to take one same example. So suppose we consider here one boy. Okay, so one boy riding their bike. Okay, I try to draw his bike. Okay, so one boy driving a bike in a straight road. Okay, here the condition is the road is straight without any obstacles. Clear? From which direction? Okay, so from west to east. So this boy driving a motorcycle from west to east direction. Okay, so the direction is fixed. Okay, without any obstacle. Okay, so the first condition is, I have to write down the first condition, the road. Okay, this one is a road, straight road, road without obstacles, road without obstacles. Okay, so the road is straight, there is no traffic on the road, there is no bump on the road. Okay, so this boy driving his motorcycle throughout this road, okay, on the road with the constant velocity. Okay, so suppose we have to assume the velocity of this motorcycle is 60 km/h, constant velocity. Okay, because the road has no any obstacles, so the speed of his bike is constant. Okay, so boy cannot reduce or decrease the speed. Okay, because the road is constant, there is no obstacles on the road, there is no any heavy traffic, there is no any other vehicle present on the road. So boy driving his motorcycle with constant speed 60 km per hour, and the road is also constant. That means the direction is also constant. Okay, which direction? From west to the east direction. Okay, so here we have to assume the two quantity are fixed. Which are the two quantity? First, velocity. Okay, here we have to assume velocity is constant, and second is direction is also constant. Here what is the velocity? Velocity is 60 km per hour is a velocity, okay, throughout the road. So throughout the road the velocity is 60 km per hour, is a constant, and direction is from west to the east, okay, W to E, okay, because it's a straight road, so the direction is also constant. Okay, so in the first case the velocity is constant and the direction is constant. Clear? Okay, now I have to pick up the second case. So in the second case, what happened? So again we have to assume the same thing. Okay, boy with his motorcycle, but the road has some obstacles. Okay, from the same direction, west to east direction. Okay, so at some stage the velocity is v1, which is 60 km per hour. Okay, and when this bump is occur, the velocity is reduced. Okay, and after bump again the velocity is increased. Okay, so at some instant the velocity is 40. Okay, at some instant the velocity is 70. Okay, that means the road, okay, here the direction is constant but the velocity is vary. Okay, so velocity is vary because the road here we have to assume road is with obstacles. Road is with obstacles. Okay, so in this case velocity is vary, but what about the direction? In this case the direction is fixed, which is west to east direction. Okay, now we have to consider the third case. So in the third case, here is the boy with his motorcycle. Okay, one beautiful motorcycle. Okay, now we assume the road is not straight. Okay, road is not a straight road. Okay, so now here for example, this one is the road. Okay, road is not a straight. Okay, west to east direction. Okay, now the road is with obstacle or without obstacle, it doesn't matter, because here there is a turn. So when the boy is driving this motorcycle and when the turn is happening, okay, so automatically the speed of motorcycle is reduced. After turn the speed is increased, again the turn is present. Okay, so again speed is decreased, again the turn is present, so again the speed is decreased. Okay, so at each and every turn the velocity of the motorcycle is different, and at each and every point its direction is also changed. Okay, so here the direction is from west to east, but now the direction is changed. At this point again the direction is changed, here again the direction is changed. Okay, so at each and every point the direction is also changed. Okay, so this one is my third case. In this case velocity of motorcycle is vary and direction of motorcycle is also vary. Okay, so here we have discussed total 3 cases. Okay, so I have to differentiate it. First case, okay, and this one is my second and third case. Okay, so now this is nothing but divergence and curl. Okay, how this divergence and curl? So see here, if velocity is constant, so we can say that there is no divergence. If direction is constant, there is no curl. Here velocity is vary, so divergence is present. Direction is fixed, direction is constant, so curl is not present. But in this case velocity is vary and direction both are vary, so divergence and curl both are present. Okay, so in a short way we can say that what do you mean by the divergence? Okay, so here we have to say that divergence is indicate change in magnitude. Okay, divergence is said that how much amount of the magnitude is change in magnitude of any vector quantity. It is indicated by the divergence. By how much amount of the magnitude of any vector quantity is change, it is indicated by the divergence. And what do you mean by the curl? Curl is indicate change in direction. Curl is say the change in direction of any vector quantity. Okay, so here we discuss the definition of divergence and curl. It's a simple definition. Okay, it's just understanding purpose. What do you mean by the divergence? Divergence means change in magnitude. Curl means change in direction. Okay, so let us consider the first case. In the first case, is the magnitude is change? No, magnitude is constant. Okay, there is no change in the magnitude. So what is the divergence? Divergence is 0. Okay, so we can say that for the first case divergence is 0. Okay, so for the first case divergence is 0 because here the velocity is fixed, magnitude of velocity is fixed. Okay, so what is divergence? Actually divergence means change in magnitude. Here magnitude does not change, it remains fixed throughout the journey, so that is why the divergence is 0. What about the direction? Throughout the journey the direction is also fixed from west to the east. Okay, so that is why curl is also 0 for the first case. Now what about the second case? In the second case the velocity is change, that means divergence is present, so divergence is non-zero. Okay, but what about the direction? Direction is fixed. Okay, so that is why curl is 0. And what about the third case? In the third case both are vary, velocity as well as direction, so we can say that divergence is non-zero and curl is also non-zero. Okay, so this one is a simple concept regarding divergence and curl. Okay, so in a short definition, what do you mean by the divergence? Divergence means change in magnitude of any vector quantity, and curl means change in direction of any vector quantity. If direction is not changed, so we can say that the curl is 0. If magnitude is not changed, so we can say that the divergence is 0. Okay, so it is just a simple definition of divergence and curl. Okay, next, so what do you mean by the gradient? Okay, so here for the divergence and curl we have to take vector quantity. Okay, always and always vector quantity, so that is why we have to take the example of velocity or speed, because as we know that velocity is a vector quantity. Okay, so next is what do you mean by the gradient? Okay, see actually here we have to study the three different definitions: divergence, gradient and curl. We have finished divergence and curl as a simple definition. Now we discuss gradient. Okay, and then after we'll jump to the Del operator. So to understand the concept of gradient, we will take the example of room temperature. Okay, I have to take example of room temperature. Okay, so because as we know that temperature is a scalar quantity. Okay, so see here, when here we have to deal with divergence and curl, this both. Okay, so always we have to use a vector quantity, and when we have to deal with the gradient, so we have to deal with the, we have to take which quantity? Scalar quantity. Okay, so what the gradient is say that? The gradient is say that how much amount of any scalar quantity is change in x, y and z direction. It is indicated by the gradient. Okay, so for example, I have to give one example so you can easily understand this concept. So this x, y and z. Okay, so suppose in x direction city A is present, city A in the x direction, city B in the y direction, and city C in the z direction. Okay, so you can say that this one is Ahmedabad, Bombay and Calcutta. Okay, and suppose this one is the origin. Now you can measure how much amount of the temperature is changed with respect to this origin. Okay, so for example, at the origin the temperature is 20 degrees Celsius. Okay, in city A the temperature is 40 degrees Celsius. In city B, let us say that the temperature is 30 degrees Celsius, and in city C it is 35 degrees Celsius. Okay, so now just how much amount of the temperature is changed in x direction? So the temperature change in the x direction means it's a difference between these two. So 20 degrees Celsius temperature is changed. How much amount of the temperature change in the y direction? Difference between these two, 10 degrees Celsius. How much amount of the temperature is changed in the z direction? Difference between these two, 15 degrees Celsius. Okay, that means how much amount of your scalar quantity is changed in x, y and z direction. So it is known as gradient. Okay, so what do you mean by the gradient? So gradient is say that change how much amount. Okay, amount of change, you can say in this way, amount of change of any scalar quantity, in x, y and z direction. Okay, how much amount of change of any scalar quantity in x, y and z direction, it is indicated by the gradient. Okay, clear? So this one is a good example to understand the concept regarding the gradient. Okay, so there are so many scalar quantity are present, like temperature, pressure, weight. Okay, there are so many scalar quantity are present. Okay, now those scalar quantity is changed by how much amount in x direction, how much amount in the y direction and how much amount in the z direction. We have to find out using the gradient operation. Clear? Actually here we have to deal with electromagnetic wave. Okay, clear? But just is a simple understanding regarding the gradient concept. Okay, so here we have finished the discussion about the what is divergence. So divergence means change in magnitude of any vector quantity. Curl means change in direction of any vector quantity. And what do you mean by the gradient? Gradient means how much amount of change of any scalar quantity in x, y and z direction. So whenever we have to deal with gradient, so we have to take the scalar quantity, and for divergence and curl we have to take the vector quantity. Okay, so now we have to jump to our main topic. Our main topic is Del operator. Okay, so what is exactly application of the Del operator? So Del operator is say that means what is the application of Del operator? So Del operator is used to find out the change in magnitude, change in direction and how much amount of your scalar quantity is changed. Okay, that means to do divergence, gradient and curl operation, we always use which operator? Del operator. Okay, that means using del we can use various type of the operation. Okay, which type of the operation we have to use? We have to do the total 3 type of the operation: divergence operation, gradient operation and curl operation. So that is why it is known as operator, del operator. Okay, so now I have to write the del operator in Cartesian coordinate system. You can write in cylindrical and spherical coordinate system. Okay, but first I have to write the del operator in the Cartesian coordinate system. Okay, the equation of del operator in Cartesian coordinate system. So here it is known as del operator. This one is a symbol of del operator. Now how much amount of the quantity is changed? Either the magnitude is changed or direction is changed or its value is changed in x, y and z direction. Okay, so in Cartesian coordinate system it is del by del x into ax unit vector plus del by del y into ay unit vector plus del by del z into az unit vector. Okay, so here I have to take, if you notice, I have to take a partial derivative with respect to x, partial derivative with respect to y, and partial derivative with respect to z. Why I have to take the partial derivative? Because whenever we have to find out how much amount of the any vector or scalar is changed in x direction, we have to consider y and z direction has a constant direction. When we have to consider the y direction, we have to assume this both direction x and z has a constant direction. Similar for z. Okay, so that is why I have to take the partial derivative. Clear? Now, suppose now I have to take any vector. Okay, now suppose consider, assume a is my vector. Okay, or not a, let us say v is my vector in this case. Okay, this case v is my velocity. Okay, v is my velocity, so v is a vector. Okay, so now we have to first discuss this case. In the first case, the velocity is constant and direction is constant. Okay, so first I have to write divergence operation and then call operation. Okay, so what is actually divergence? So divergence is if, okay, I have to consider v vector. So what do you mean by the divergence first? So divergence is change in magnitude of any vector. Okay, and in mathematical you can write divergence is nothing but is a dot product of any vector quantity with del operator. It is known as divergence. So this operation is known as the divergence. Okay, I again repeat, divergence means it's a dot product of any vector quantity with del operator. It is known as divergence. Second, what is curl? So it's a change in magnitude. Sorry, curl means change in direction. So to change in direction, we have to use the cross product. So curl means cross product of any vector quantity. Here it is vector a, b, c, d. Okay, you can write any vector. But what is curl? Curl means cross product of any vector quantity with del operator. So it is known as curl. Okay, see here, you cannot say that this one is my curl, a cross b. It is not curl. Why? Because here it is vector a and vector b. There is no del operator. So this one is not a curl. Okay, you cannot say that this one is a curl operation. But if you do this one, so now this one is curl. Okay, so it is known as curl because it's a cross product of vector b with del operator. So it is known as curl. Similarly, you cannot say that a dot b is a divergence, but del dot b is a divergence because as a definition, divergence means dot product of any vector quantity with del operator. It is known as divergence. Okay, now how to remember it? Divergence and curl. So it's a very simple. Okay, the first letter of divergence is d and I have to put a dot. So the first letter of dot, d-o-t, d. So d and d. So d means dot. Okay, similarly c means cross. I have to use a cross. Okay, so that means c and c. Clear? So in divergence means dot product of any vector quantity with del operator, and curl means cross product of any vector quantity with del operator. It is known as curl. Okay, and I have to say, suppose T, temperature, because V velocity is a vector quantity. Now temperature, I have to consider the temperature because temperature is my scalar quantity. Okay, so now it is the concept of gradient. Okay, so gradient means is a simple multiplication of scalar quantity with del operator. So it is known as gradient. It's a simple multiplication, not dot product. It's a simple product. Okay, not multiplication, but you can say that it's a simple product. So say if you do the simple product of any scalar quantity with del operator, so it is known as gradient. It's not a dot product, it's not a cross product, but it's a simple product. Okay, this one is my simple product. Okay, so it's a simple product of any scalar quantity with del operator, so it is known as gradient. Okay, so here there are the few definition of divergence, curl and gradient. Now I have to apply my concept with my 3 case. Okay, so here I have mentioned the 3 cases. Okay, so in the first case the velocity is constant, so that is why the divergence is 0. Direction is constant, so curl is 0. So how can I write it? So divergence is 0, that means I can write in this way: del dot velocity v is equals to 0, because this one is my velocity, which is a vector quantity. Okay, similarly the curl is 0, means del cross v is also 0 for the first case. What about the second case? Divergence is non-zero, that means del dot v does not equal to 0, but curl is 0. It indicates del cross v is equals to 0. And in last case both are non-zero. Okay, so del dot v does not equal to 0 and del cross v does not equal to 0. Okay, and what about this one? Gradient. Gradient means I have to write del into t, so it is indicated by the gradient. Okay, see here, suppose the reference temperature is 40 degree. For example, the reference temperature is 40 degree. Okay, so if I have to take, okay, if I have to find out how much amount of the scalar quantity change in the x direction, so here at the reference point the temperature is 40 degree, in city A the temperature is same. Okay, so it is 0. Okay, so there is 0 amount of change. Okay, that means no amount of change of scalar quantity. So in that case the answer is 0. But what about in this direction? It is 10 degree change, and here 5 degree change if I have to consider the reference temperature is 40 degree. Clear? So it's a very simple understanding regarding the concept of divergence, curl and gradient. Okay, so again I have to repeat what is divergence. Divergence means change in magnitude of any vector quantity, curl means change in direction of any vector quantity, and gradient means is how much amount of your scalar quantity is change in x, y and z direction. It is indicated by curl. Okay, so here I have to just write the equation of del operator. Clear? Okay, so now in next lecture we will discuss about the equation of divergence, curl and gradient in all the coordinate system. Okay, see actually what we want that all the 3 quantity in all the 3 coordinate system. Okay, as we know that there are the 3 coordinate system: Cartesian coordinate system, cylindrical coordinate system and spherical coordinate system. Okay, similarly we have a concept of divergence, concept of curl and gradient. Okay, so now in next topic I have to relate divergence in xyz coordinate, divergence in cylindrical coordinate and divergence in spherical coordinate. Similarly, curl in Cartesian coordinate, curl in cylindrical coordinate and curl in spherical coordinate. Okay, and similarly gradient in Cartesian coordinate, gradient in cylindrical coordinate and gradient in spherical coordinate. Okay, so in next lecture we will discuss about the definition of divergence, curl and gradient in all the 3 coordinate system. Thank you.